So, do you think it's the right time to start?
Yeah, Nico,
Yeah.
I think so.
Okay, so welcome everybody to the session 2. This is a session related to storage and especially the role storage plays in the integrated energy networks. So we would like to see how storage is extremely important, how important it is in the flexibility of the operation of the overall system, and also as a source of flexibility in operation and in planning, of course. I think we have an interesting session. First, let me ask my co-chair, Mr. Franco Di Persio, to say a few words about him and to introduce himself.
Yeah, thank you, Nikos. Good morning to all. Franco Di Persio, and working in CIRSE, Fundación CIRSE in Spain. And I am a member of Working Group 2 on energy storage system integration. So that would be really interesting to hear from you. What are your issue, your solution to transmit then those information for RNI input within the ETIP, and then to the other stakeholders and the European Commission.
Thank you, Franco. And I think it's time to probably move to the presentation of the various projects. Or first, let me introduce the panelists and give the word to them for just to introduce themselves and say a few words. We have the pleasure of having with us Nico Aspiri Irazabal, who is the ETIP SNET Vice Chair. So, Nico, can you just say a few words?
Yes, thank you for your presentation. As you said, I'm the Vice Chair of ETIP SNET in representation of IS, and I currently work for Iberdrola. I'm part of the global engineering, and I lead the part on the definition of the requirements for our battery projects worldwide.
Thank you. Then we move to Silvia Bodoardo.
Yeah, thank you. I'm Silvia Bodoardo from Politecnico of Torino. I'm here representing the Working Group 2 of ETIP SNET, and I'm also co-chairing the Working Group 3 of Batteries Europe. And I'm mainly working on batteries by materials to recycling point of view.
Thank you, Silvia. Then we have Georgios Christoforidis.
Yes, good morning. Thank you for the invitation. My name is Georgios Christoforidis. I represent here the Working Group 3 of ETIP SNET on flexible generation. And I'm also in the University of Western Macedonia in Greece, where we are facing the region a huge decarbonization process and the transition due to the so-called taking away of all of the fossil fuel power plants that were in the region. So yes, I think we will have a fruitful discussion today on integrated energy networks. Thank you very much.
We are looking forward to that, yes. Then we have Gianluigi Migliavacca.
Thank you, Nikos. I have the pleasure to be in this meeting, and I'm the coordinator of the project Flex Plan, which I will present in a couple of minutes during the 99-second pitch presentations. I'm a coordinator of a Horizon 2020 project for the second time and of a European project for the third time, being the former projects SmartNet and formerly Realize Grid. Thank you very much.
Thank you, Migliavacca. The next speaker will be Jean-Jacques Frey of Hydropower Europe.
We cannot hear you, Jean-Jacques.
Thank you. Sorry. I am Jean-Jacques Frey. I am the current chairman of the European Club of the International Commission on Large Dam, and I am in the management team of the project Hydropower Europe. We will be complete this year.
Thank you very much. Of course, hydropower is very important as a storage component. So that's very good. And then we have Nathalie Grisset from RTE France.
Good morning, everyone. So I work for RTE, the French transmission system operator, in the R&D department, and I have the pleasure to be the coordinator of the Osmose H2020 project, which I will present later on.
Thank you. Then we have Mr. Shafiq Kadem from EIRC.
Good morning. This is Shafiq Kadem from International Energy Research Center in Ireland. Yeah, I'll be presenting about the StoreNet, one of our national project, industry funded and the government funded collaborative project. So yeah, we'll be talking more in the speech and the panel discussions. And I'm also part in the working group 5, member of the working group 5. Yeah, thanks.
Thank you. Thank you. That's also interesting because it's a really regional project, while most of the other projects are Horizon or pan-European projects. And then we have Miss Mia Ala Juesela from VTT, Finland.
Yes, hello. From VTT, the Technical Research Center of Finland. I'm a senior scientist in the team of urban energy systems. So, and I was the coordinator of STORY project, which ended last October already. And I have some very interesting findings to present from that project.
Thank you very much. We are looking for a very interesting panel. I think we try to collect the some of the most interesting projects at the European level, at local level. So, having said that, well, that's organizational rules. Well, I think we can understand all this. This is how we join the conversation. We know that already, right? And now we start with the Slido questions. This is the same code we used before, right?
Yes, I think so. This is in code. Yeah. Yes. Okay.
Yes, so please go to Slido and we will show the first question to you.
Okay.
Okay.
So, again, this other factor is very important here. I don't know if it is only consultants or who it does, but clearly we have a strong participation from research institutes and technology providers, and then universities, we have distribution system operators, transmission system operators, energy utilities, and this makes up our group here. So thank you very much for this.
Next question, please. Okay, and then thank you very much. Next, the next question. Would the moderators like to comment a little, or is it okay?
I'm sorry, I cannot see. Oh.
Ah, okay.
Yes.
Okay, I can, because I can comment.
Please.
Yeah, okay, indeed. So the most represented is the. Can you send go a bit up? I cannot see. Ah, okay, flexible enable and system flexibility and system operation. So indeed, that's are the most represented here in our session. Yeah, more than 70% indeed.
Yeah.
Okay, maybe we can go to the next
but,
one.
Let me just say one word
Nikos,
here that, of course, flexibility is something we use for operation as well. So I won't easily distinguish what is flexibility and system operation. I mean, batteries can be used, of course, to provide flexibility also for system operation, right? So I would say that, and there is some kind of overlap in these two categories. So clearly, of course, providing flexibility in system operation is the most, indeed the best, the most researched area in what we are doing here. Thanks. Okay. And then? I'm sorry, I cannot see the slide very well here. I don't know if something is wrong. Is there any more questions, Xenia?
No, the session, the questions are over. I will share the slide, the PowerPoint again. Sorry.
Okay.
Yeah.
So now let's move to the projects and let's ask the first project. I mean, let's ask Gianluigi to present us the RSC Flex Plan project.
Okay, thank you, Nikos. So please, next slide. Okay, so FlexPlan is a Horizon 2020 project aiming at establishing a new grid planning methodology that considers the opportunity to introduce new storage and flexibility resources in electricity transmission and distribution, so joint T&D planning, as an alternative to building new grid elements. So the big novelty of this project is to consider a new planning methodology that is able to encompass not only traditional lines reinforcements, but also including flexibility elements and in particular storage. We are 13 partners from 8 European countries, including a lot of research organizations. Coordinator is RSC, my company, myself. And then in particular, I want to signal 3 transmission system operators that are Turner and Ellis, and a big concern of distribution system operators that is the Enel group. Please, next slide. Okay, so what are we going to achieve? So first of all, a new planning methodology. So a new set of tools, one for the optimization of the planning and one for creating a set of candidates to work upon. To optimize T&D joint planning by considering the placement of flexibility elements both in transmission and distribution networks as an alternative to traditional planning. Then, of course, once the methodology is set, the tools are developed, and then we don't use only those tools in order to, so to say, validate the methodology, but we make an extensive use of them within 6 regional grid planning scenarios at 20, 30, 40, and 50, and the 3 grid years are solved all together. Then the results are not, I said, only used in order to validate the set of tools, but we use them in order to provide a picture on the evolution, possible evolution, optimized evolution, if you want, of the system, and in particular to elaborate guidelines on what role, the potential role of flexibility and storage as support of TNDA planning. And those guidelines, of course, we hope can be useful for national regulatory authorities and other stakeholders. Thank you very much.
Thank you very much. That's very interesting how storage can help in planning. So the next presentation is about hydropower. So I would like to invite Mr. Jean-Jacques Frey.
Thank you, Mr. Chairman. I am glad to introduce hydropower, and my wish is you remind that hydropower is a catalyst for the energy transition. We belong to the others organization. I mean, we are a coordination and support action funded by the European Commission to develop a research and innovation agenda, RIA, and a strategic industry roadmap, SIR. The research and innovation agenda identifies priority research themes covering all aspects of hydro generation, and the strategic industry roadmap identifies priority strategic action for the industry to address. So together, these provide a plan of action to support a greener, more efficient, and an effective role for hydropower in supporting the European green energy transition. Next one. So our vision includes promotion of new environmentally friendly multi-purpose hydropower scheme by using hidden potential in existing infrastructure, increasing the flexibility of generation from hydropower plants by adaptation and optimization of infrastructure and equipment, combined with innovative solutions for the mitigation of environmental impacts. Increasing storage of existing dams to help ensure flexible energy supply and support food and water supply, hence contributing to the water, energy, food nexus and achievement of SDG. And finally, strengthening flexibility of supply from pumped storage schemes, developing innovative arrangement with existing water infrastructure. To conclude, we have to know that hydropower accounts for more than 1/3 of renewable power in Europe in 2019, and globally in the world count for 90% of the flexibility. Thank you.
Thank you very much. That concerns now mostly pumped storage, right?
And you have a large flexibility as well with classical storage hydropower plant. And we could improve that with innovation and changing the turbines, the equipment, the gate, and so on.
Okay, thank you very much. I would like now to invite Ms. Nathalie Grisset. Tell us about the Osmose project.
Thank you. So the OSMOS project is a project about flexibility where we have a big involvement of transmission system operators. In the project, we have 3 large-scale storage demonstrators. The first 2 on the upper part of my slide are dealing with the demonstration of grid forming. So grid forming is a new service which would be required in system with high res penetration. And this service requires energy which would be available in a short time. No, cannot see my slide anymore. Thank you. So in the project, we wanted to demonstrate the provision of this new service by 2 off-the-shelf storage systems. And so we did so successfully. The 2 systems we tested, so the first one was developed for the project, and it is a hybrid system with supercapacitors and lithium-ion battery. The second one was existing before the project, but we upgraded it to perform this new service, and it was a battery lithium titanate. The 2 are around 1 MVA in size. On the lower part of the slide, you can see our third demonstrator, where we developed a high voltage battery integrated in a modular hybrid device, combining also STATCOM and supercapacitors. And we worked on the optimal design of this device in order to reduce the cost of around 10%. And this new device, we will test it for the provision of different grid services, basically. So the first 2 ones are led by RT, the French TSO, and the one on the lower part of the slide is led by Red Eléctrica, the Spanish TSO. Next slide, please. In our project, we are also studying the role of storage in long-term scenarios for Europe. So storage in that case means battery, but also hydropower, just like it was mentioned in the previous presentation, and also power to heat. We are also studying power to heat. We are building on our experience also to develop generic methods for the optimal design and control of battery energy storage systems. And we are also developing a shared feedback database from field experience of battery energy storage system to enable a share of best practices between operators. So these works are led by the CEA. Thank you.
Thank you very much. So is it right that I understand that these batteries mainly support voltage at the transmission level? Or do you provide other services?
No, they provide different services. So the first one I mentioned on grid forming, it's not only voltage. Basically, it's behaving like a voltage source. So somehow it supports voltage, but not only voltage. And the second one, we are studying various services, including voltage, but also frequency regulation or congestion management. So, okay. And we have a focus on also demonstrating how we can combine different services, basically, how storage system can provide different services at the same time.
Thank you very much.
Thank you.
The next presentation by Safi Kadem from Ireland, the StorNet project.
Yeah, good morning. So it's a long story, but in a short, the thing is the solar energy aggregator who actually came to us in 2017 with their FlexiGrid platform, which they have developed to provide some sort of aggregation services, but they're thinking to do it in including storage. So they want the storage to be installed in the residential network behind the meter. So how this can be done and what type of services can be provided to benefit to the consumers and also for the network operators. So then we actually move ahead with our distribution network operator, ESB networks, and also we think that it will impact on the utility supplier. So we went to the Electric Ireland with the utility supplier. So they are the consortium partner. And we, the International Energy Research Center, work together to find out a real-life demonstration network where we can demonstrate the distributed energy storage systems behind the meter in the low voltage network, but it's also a weak network in the southeast part of Ireland, which requires some sort of voltage support in the network. So we work together and then we develop the solution in the real life, and we develop these integrated energy system solutions together, and that's provide some sort of mitigating the real peak demand with the voltage profile improvement, and also provide grid services in terms of these primary operating reserves, which are also demonstrating the service to the transmission network as well for their ancillary services. We also developed some sort of algorithms to provide how different sorts of control algorithm could help to improve the VPP platform in terms of the energy arbitrage, peak shaving, and the load leveling, and also shows that how utility supplier can be benefited from all these things. So throughout this project, we have lots of learning. That's how to deal with the regulations and the funding mechanisms, and the ICTs in important issues there also, and how to engage these consumers into this overall demonstration and the real interesting project. So next slide, please. Yeah, so the deployment prospect is very high. Actually, we proved this concept that how these distributed energy storage systems can be worked together to develop a virtual power plant and to provide services to the network, as well as the benefit for the consumers and the stakeholders, relevant stakeholders. And the proof of this real demonstration and the verification of this VPP platform, the flexibility software solutions. Yeah, it is highly efficient and intelligent solution. It's a high prospective and replicable features. So we find some future research work as well that how the consumers can be interested in the DSM participations. But one of the important thing as well, that when you go for this VPP control or things, how it helps or impact in the power quality of the network as well. So we are missing this part. So yeah, and how in future they can participate in the energy trading mechanisms as the local energy market is now booming up. So if you want to learn more about this impact of this real case, there is a YouTube video also there where the participants, the consumers actually express their real interest and how this project is really helping them in saving their energy consumption. So yeah, that's all from my side.
Thank you very much, very interesting. And the last project will be presented by Ms. Mia Alla Yusela from VTT.
Thank you. Now I'm also not muted anymore. Well, the story project was set up to show the added value that storage could bring for a flexible, secure, and sustainable energy system through small-scale demonstrations and large-scale simulations. With 6 demos ranging from building to neighborhood scale, from industrial to residential buildings, including different types of thermal and electrical storages, the story team tested several scenarios for small and medium-sized storages. They developed control strategies, key performance indicators, and business models for the demos. The economic, environmental, and social impacts of the demos were assessed, and recommendations to the regulations were provided. The large-scale simulations showed the potential impacts on the grid level. And next slide, please. The challenges faced during the demos showed that the market is not fully mature yet. There are important challenges in the interoperability and an obvious lack of integrators. The business models would require stability on the regulations, which are, however, just developing at the moment. The robustness of the system, minimum need of adjustments and maintenance is crucial for the economic viability and acceptability. Technical, social, and market issues are highly interrelated. Good user engagement will help mitigating the technical and market issues and vice versa. The environmental analysis showed that the environmental benefits are only acquired with important share of renewables in the grid. Based on the learnings, the story partners developed products and services, and some of them started the exploitation already during the project.
Thank you all for these very interesting presentations. I think we really have covered a very a wide spectrum of storage applications, starting from planning applications, then going to the transmission system operator, large storage projects, covering the issue of the important hydro storage. Then we talked more about distribution system storages, and covering again several aspects, including thermal storage. I think we really have a very good and overall view of the storage applications today, both in planning and operation, both transmission and distribution level. So now let's move to the panel discussion. There have been some questions that we have already prepared. Of course, if you want to add something, feel free to complement these questions. Let me start perhaps again from the projects, and then we would go to the other members of the panel who represent working groups to provide also the reviews on these 4 questions. So let's start again from Gianluigi Villavaca.
Yes. Thank you, Nikos. About barriers for storage deployment, I think that there are many issues that should be tackled in the next years. For sure, there should be a clarification on the status of virtual power plants and its relationship with the energy communities. That is a source of future regulation, because it's a sort of new territory to be explored. There should be, that is in my opinion very important, a clarification for the figure of the aggregator, because the aggregator is the central position in order to enable market access to small entities that normally cannot be treated directly in real-time markets, especially so those markets that are devoted to services. And of course, this aggregator position should also not only have a more clarified status and regulation, but also clarify if there are some sort of incentivization policies or something like that that could make it possible, viable to create a business model for this figure, of course, that should take, of course, the reasons for enterprise. Storage ownership is an old issue, and I have not to remember the fact that in any case the positions are still quite different and should be better clarified. And finally, about the access to the market, I think that special products in order to allow level playing field access to the markets, especially real-time markets for flexibility, and in particular storage, should be elaborated, because those entities are very peculiar, peculiarities, and so I think normal products that were tailored time ago on participation to real-time markets from typically big conventional power plants should be integrated with new products. So finally, I think that in a situation in which ownership of storage is not necessarily also, or in any case, discouraged to be in the hands of system operators, as it is the tendency nowadays, I think that some clarification should be brought from the point of view of what kind of incentivization for settling new storage should be provided in order to get an optimized situation in terms of investments that could reflect the needs highlighted by the planning documents of the system operators. So there should be sort of a triangle between system operators, national regulatory authorities, and new investors. And that triangle should be clarified from the regulatory point of view.
Thank you very much. Let's take the same question by the other panelists, and then we go back to the last 3 questions. So who's next? I think the next speaker is Jean-Jacques. Is there something you would like to say about the regulation and the main barriers in developing hydropower technology? If not, we can move to the next speaker, who is Nathalie, you say?
I think Jean-Jacques wanted to speak, but he was muted.
Sorry.
Thank you. Yes, I was muted.
Sorry. Sorry
yes. You know, storage and flexibility are externalities from intermittent and variable energy. And usually, externalities are not taken by the market, but they are taken by regulation. So it's why regulation barriers are now the main problem. There is a missing money problem for flexibility. Why all services provided to the grid should not be fully compensated according to their value. This question is central. Other barrier from regulation could come from not enough effective European emission trading scheme giving a price to the carbon. We need a higher price to go quicker on transition energy. Another aspect is the concession duration. We need long duration concession. Why? How the owner could invest for energy transition if the concession stop in 10 or 20 years. And that's a pity because we need to invest for 2035 or 2050. About market barrier, we need only to ensure a level playing field between technologies. And we need as well global, I would say, an economic model for flexibility, integrating all renewable energy in order to have the full picture of the future energy system and to understand how all this renewable energy could be integrated in the future energy system. Thank you, Nick.
Thank you very much. Thank you. Well, okay, we'll come back with other questions later. So let me now ask the same question to Nathalie.
Thank you. So as a transmission system operator, as I'm representing a transmission system operator, for us it is important to have not to favor any technology. So storage is one among the different technologies which can provide flexibility. But still we need to understand how it works. For example, in the project we are working on electrochemical storage, because we need to understand what they're capable of doing, what are the constraints, so that we can define the proper rules for the connections typically, and so to take them properly into account in our different mechanisms. Yes, we need to understand them more. So that's where we're doing thanks to our project. Also, I think one still barrier that we have, of course, is the cost of storage, which is still high for certain services, for the provision of certain service. Still in the project, we are trying to lower the cost via different actions, but still costs are still high. And also we can see that in some flexibility services, when you have, let's say, more and more players and more electrochemical or whatever storage that will arrive, there might be some kind of cannibalization of the benefits, meaning that the more participants you will have, the lower the benefits will be for each. And so that's might be an issue in the long term to ensure a proper revenue for the storage actors. And also I want to highlight that we're also wondering about the environmental impact of some storage. So for example, electrochemical storage for sure, because it's not always looked in the different project, but still it must be taken into account and in the big picture of the global impact of the system, because for sure, for example, improving the penetration of renewable is a good impact on the environment, but you also have other impacts that needs to be taken into account if we want really to have a clear view on the different benefits of the storage systems.
You started touching the last bullet as well. But
Yes, sorry.
Okay, let's now go to Safik Adam. What do you think about the main barriers?
Yeah, so if I would say there's like what you face very firstly in the LV network, in the distribution network behind the meters, that in Ireland we didn't have any kind of regulations for the battery separately. So that's one of the important things. I don't know that most of the other countries also doesn't have, I think. So what we had to do actually, we did it through these our micro generations policies, the regulations that what regulations that follow the micro generations about all this grid code and everything. So we have to follow these rules. So I think that's one of the things that we should have separate regulations for these storage when it connects to the depends on the actually where we are actually connecting. It's behind the meter in the residential network, and what are also, I think it's the purpose of this storage. So my understanding is that if it is for grid services, then we should have something different about its charging and costing. In terms of its, because in some spaces I know there's when it works for the MV or HB network, so there's a double charging phenomena is there in some places. So I think that also could be give some thought on this thing, that because in that case, if the storage is dedicatedly for grid services, then I think we should have some different regulations for these things. But if the storage is for both like grid service and or only for the consumers, and though it's indirectly helping to the network, but I think yeah, there could have different regulations as well. So yeah, that's are the main barrier at this level, I would say, from the regulations point of view. Yeah, from the technological point of view, that's okay. I mean, the technology is growing. The cost is a little bit also is not reachable to the consumers. Actually, much supportive on these things. So that could be an issue also. And yeah, so these are some of the things very much important.
So I understand regulation and cost are the main factors you see as barriers.
Yeah, that's definitely, because when we see in the consumer end, if we want to place it, then definitely it's an additional cost for the consumers. There should have some sort of more incentive. There is some incentives in Ireland, but I think it's also should have some sort of other benefits as well. But when you dedicate it for these storage, we use it for some sort of technology provider like grid services, who provide only the grid services. So that's a different issue. So that's their dedicated. So some sort of yeah, different regulations and mechanisms should be there.
Okay, clear. Thank you very much.
Yeah.
And the same question to also to Miala.
Yes, as I mentioned, we learned a lot in the story project. And one of the learnings is that in the frequent changes in the regulations create a lot of challenges in developing the business models, the related optimization strategies and control algorithms. For example, in the Spanish demo, the partners needed to develop 3 different control strategies in the 5 years project. And due to the changing regulations. And we also found some gaps in the building permits and fire safety regulations. Regarding the market, there are several challenges. One of the biggest is the low market liquidity. The storage technologies are mostly there, but the storage as system is still missing, and it was not available in the stage you would expect, and is marketed. And during storage, the response times were really slow, and there was a serious lack of maintenance services, for instance. It's like compare the car, you have the engine and the wheel, but the steering wheel is missing. You can find some, but it's not necessarily compatible with your car. And actually, one of the most important learnings was that due to the frequent changes in the market and regulatory environment, it's very important that the system is robust and flexible, both the storage and the control systems, in order to make it technically and economically feasible. There were problems in interoperability that need to be developed. And also, as the storage implementation needs a good understanding of the systems, potentially a storage as a service could be a solution for this. Some of the learnings. I have much more, but let's talk something else also.
Okay, thank you very much. Does anyone of the working groups would like to say something about that?
Yes, if I may, I agree with most of the things or everything that has been said. Just to add a few more points to the issues on regulation. I think that it's important that the services that storage provides need to be properly remunerated. So these services, as the penetration of renewables increases, will be more and more important. So in some countries, not all of the services, for example, frequency regulation, are remunerated. So in this sense, we should pursue this objective. Also, that we should have long-term contracts because the technology, especially on batteries, is evolving very quick and all the time. So when you prepare a project, you get a price, but then the technology is half as cheap in just 2 years. So new projects can come and compete with yours. So long-term contracts, I think that will be very important for the establishment of the storage technology. Also, regarding grid feeds, I think it's important to remove the double charging. I mean, when the energy is charged, you're paying for grid feeds, but also when you're discharging in some regulations. And well, as Mia said, it's important to have a quick regulation. Some countries in Europe are quite evolved on this, but others, like for example in Spain, are just beginning, and as Mia said, the regulation is changing. So this is stopping the development of the technology in some cases. And then in more technologically related issues, I think the main problem is that the cost is quite high, especially on batteries. And I think that the cycle life should be improved and the cost reduced. Investigating on new materials, increasing the amount of recycled materials in the batteries, and a longer life is important because these storage technologies start degrading as soon as they are manufactured. So, for example, from our point of view in Iberdrola, it's common that the projects have delays. So if you have the batteries in a warehouse waiting for being installed, like for a couple of months, the degradation is quite high. So this affects the business of the project. So in this sense, we should investigate on this.
Thank you very much. That's a very complete answer. Thank you.
If
Are there any other points to be added, please?
If I may add, starting from what Inigo was saying, Cost is for sure a big issue, but there are some points related, for example, to different countries. If we consider, as an example, the battery of a vehicle as one of the nodes of the system, so that can take the energy and give the energy when needed, but the car is moving from one country to another one, we need to consider regulations that allow these aspects also in different countries with the same vehicles, as an example. And then that vehicle is also a property of someone. So the use of own storage system, in particular when distributed, cars are an example, but there are many, should be strongly regulated, but also, let me say, at European level more than country by country, as then, you know, and current and energy, electrical energy in particular, is moving from one country to another one. And so we could not get different regulation, in particular storing that energy produced in one country and distributed in another country, different if we are in Europe, as an example. So, and then there are also taking into consideration electrochemical storage system, other aspects related to regulation of transportation of batteries in particular, because, you know, these batteries are produced in gigafactories. Now, most probably they will be produced in gigafactories in Europe, but then they have to move from one place to another one. And considering how fast chemistries and are changing, we need to regulate safety aspects related to the transportation on one side, but also on the use of battery itself. With this, you know, so strong and fast changing in the storage system. And of course, someone already pointed that sustainability and, let me say, recyclability has to be one very strong key point that should be regulated. And anyway, we know some of the recycling methods, some of the materials contained in the electrochemical storage system in particular, which I know better, are not cost effective when recycled. If I have iron as an example, there's no advantage to recycle it. But regulation here can play an important role in order to reduce the number of wastes.
Thank you very much. That's also very interesting. And anything else, please? Yeah.
If I may add something from my side, I think that storage can have several benefits for the grid, especially, but I think there is a lack of different markets at the moment, like ancillary services markets that are quite in an early stage of development. Also, other markets like could appear in the future, like transmission, upgrade, deferral markets, or avoidance. The thing is that storage can do a lot of things, but these are not monetized at the moment. So this removes streams of cash from the investors. And this is a problem at the moment. The cost issue is still valid, although we do see that records of new installations happen every year. So this is diminishing, I think, especially for battery storage. And there is another thing that I would like to point out related to our activities in Working Group 3, Flexible Generation, that is the seasonal storage, which is strongly related with the overarching topic of this discussion, the integrated energy networks. We believe, and we have highlighted this in our last year's white paper, that in order really to to succeed in a decarbonized Europe by 2050, we would need so many new variable renewables in the system that without a kind of seasonal storage, where we will not be able to harness and include everything and use everything for the demand. And when talking about seasonal storage, apart from traditional applications and solutions like hydro dams, we know that they are difficult to be built. We are mainly referring to types of storage like hydrogen storage, or even green fuels that we will be able to use in the traditional thermal power plants. So this is something very related with the evolution of integrated energy networks, and this is something that should be taken into consideration in both planning and operation of electricity systems, hydrogen networks, and other energy networks that should clearly try to find ways to communicate better and plan all together their operation.
Thank you very much. Now I suggest to move to another question. I don't know if Franco would like to lead the discussion in one of the other questions. I would think that perhaps the bullet number 3 and 4 are quite important. You already heard about the bullet number 2. So Franco, would you like to lead the discussion here?
Okay, so let's go to the number 2 then, no?
Okay.
So, okay, thank you, Nikos. The question is, what is the size and what are the technology used for the services in your project and in your experience? So we can start with Gianluca Migliavacca.
Gianluigi, yes. Thank you very much.
Sorry.
No, not a problem, not a problem. So as our project FlexPlan is analyzing the possibility of technologies to storage and flexible technologies to support system planning, of course, we are interested to analyzing every kind of technology in principle and every kind of size, of course. Most of the technologies that are listed in this question are already actually within the range of investigation of our project. What we do is actually, that is the central point, is to match technology and size with the kind of congestion you have to solve in order to provide candidates for specific nodes, also like take into account possible restrictions that the topology and other environmental conditions of the node can provide with respect to some of those technologies. So in order to extract the preprocessor to create candidates that then are used by the planning tool in order to set the best planning strategy. So in order to do this complicated operation, because it's by no means evident what to do, we use on one side some rigorous mathematical formalization, like of course Lagrange multipliers, PTDF factors, and so on. But on the other side, we also use some heuristic principles that we use also in order to cope with the big diversity, because we treat hourly problems for 3 years, 3 grid years that are 20, 30, 40, 50. And we also use in a Monte Carlo approach different climate variants. So that give rise to different kind of variants of the scenarios that are to be considered. So this manifold of data that we have to compatibilize, take together in order to understand which kind of technologies and size should be proposed for each node where congestion is insisting. I think they use some information like the number of congested hours and the size of the congested line that is...
I'm sorry to interrupt you, but for the interest of all speakers, can you please just answer the question and don't describe the whole project, otherwise...
No, I'm not answering. Of course, I'm trying to answer. So we are targeting the whole size of sizes of technologies and of course the different kind of technologies. So I was just trying to explain why those technologies and those sizes are used in a complicated, so to say, methodology in order to provide useful information for our assessment. But please, let's see.
Yes. Thank you, Gianluigi. No, indeed, then there isn't no unique, of course, there is no unique solution. There is always to be chosen accordingly to the environment, to the context. So let's hear from Jean-Jacques. So what is your opinion on this size and technology mix?
Thank you, Franco. Hydropower can provide all sizes of storage. For instance, runoff river hydropower plant with bondage hydro could provide some megawatt during half an hour to a couple of hours. And we have medium storage with a storage hydropower plant up to several hundred megawatt from several hours to several months. And finally, with a pump stage hydropower plant, we could have very high power up to 2 gigawatt and during 5 up to 100 hours. That's the kind of time scale and power scale. Thank you, Franco.
Okay, thank you. Thank you, Jean-Jacques. Yeah, of course, the hydropower has this big flexibility, of course, for its nature. So let's hear from Natalie.
Yeah, thank you. So in our project, we are doing long-term studies. So just like mentioned by Gianluigi, we have this issue of the different storage type of storage, which are somehow in competition, and it is not always easy to model all the different options. And we can see, yes, it's a big challenge. But in our demonstrations, we have only electrochemical storage on the size around 1 MVA, I would say. So for the batteries, we have two of them are lithium-ion batteries, and another is a lithium titanate battery. And yes, maybe one comment on the size. So for our demo, the long-term target is to install the demo in the Canary Island. Thus, the size of the system is quite relevant to have a big impact because it's an island. So basically, it's a small system. But on the other demo that we have, so for sure, 1 MVA, for example, is very small to see a big impact on the system so far. But we are more studying, let's say, what is this capable of doing, and for sure to have real impact on the system would need much more.
Sure. Okay, so you need to scale up for some of the system.
Yeah.
Okay, thank you. So Shafi, from your side.
Yeah, I think that's what we find. Basically, we are dealing with this distribution network, LV network, and all these storage capacities are very small, few kilowatt. The problem here is more, actually, I would say it's very much challenging when you deal with this distributed storage, or not only storage, I would say distributed energy resources in the LV networks. As you know, there's lots of power electronics interfaces there. So the power quality is very, very important here to maintaining the power quality into the LV networks, and definitely storage is helping the consumers and also supporting the grid network. But it's more actually how better way we coordinately control these devices. So that's really very important here. And also the other issues also come that where we are placing in the networks, the single phase, 3-phase networks, and how we are controlling all these things. So it's unbalancing issues are also coming there. So these things are actually, I think there's placing in the storage, as we said, that's okay in our EU actually now more focusing on these consumer active participations in the network, so in the energy market. So there are more involvement, and definitely they are moving for more DERs and also including storage, and also we are thinking about these EV charging facilities in these networks. So it's really becoming very much challenging, I would say, in terms of controlling in these distributed solutions in the LV network especially. So yeah, we have to do a lot of things there, and I would say this that's from our practically projects we really find that's these power quality unbalancing issues are there, and these things should be considered into these controlling method and mechanisms, and that definitely will impact in the market as well. So yeah, plenty of things still have to do in this, especially when you deal with these LV networks for these storage and the other DERs.
Yeah, thank you, Shafi. Yeah, indeed, power electronics and the power quality are there, no, to deal in the mix. Of course, it's not only a matter of technology, of course, of the storage system. Yeah, indeed. So, and Mia Ala, your point of view.
Yes, in Story project, we tested a lot of different small and medium-sized storages to see how they can support the grid. And we had industrial and residential areas, we had building and neighborhood level, we had thermal and electrical storages, and we even tried to test the compressed air energy storage system, but that had to be stopped at demo because the technology wasn't ready yet at that point. But I also want to mention that it was also important that we also tried different other flexibility options, like using the building shell as thermal storage, or then also some of the electric vehicles. And the sizes, they were like from some tens to several hundreds kilowatt hours. And the batteries, there were different types of batteries, lithium-ion, lead-acid batteries, and we also tested some flow batteries and whatever, all shapes and sizes of storages.
Okay, good, interesting. And you have noticed one that is winning compared with the others?
I would say that we need everything. We need all. It's not wise to put everything in the same, as you put all the eggs in the same basket, as they say. So that it's better to use all different options and try to find the best use for all of these options.
Yeah, indeed. Thank you. And okay, so maybe Nikos, you can take the following question.
Thank you, Franco. Yeah, just there's an interesting question on what's your experience from practically applying storage? What functionalities have you used? Unfortunately, there is not much time, so a quick answer would be really appreciated. I mean, how do you use storage for frequency regulation, for renewable energy balancing, for time shift, for reverting investments, or what are the main use you have seen in your projects? So let's start again from the beginning.
Okay.
Let me please, Gianluca.
Gianluigi,
please.
Okay.
Please.
I will be very, very short because I can refer completely to the presentation, the two slides that I have shown at the beginning. So we address the possibility of flexibility, and in particular storage, to be part of the planning process for the grids, to transmission and distribution grids. So the service that we are addressing most notably is congestion management, of course. And well, I think that this should respond to your question. So.
Thank you very much. Thank you, Gianluigi. Next presenter was
Nikos,
Jacques. Yep.
Yes. You know that hydropower could provide all kind of service. By the way, in the future, I think hydropower will share this service, and we give room for other technology. For instance, we have successful trial using battery for very short time scale, about some second or some millisecond. And in the future, we could have long duration storage with hydropower, with hydrogen. It means that we are thinking about hybridization of the service. Thanks.
Thank you very much. Let's move to Natalie.
Yes, so one challenge that we had in the project, so we are two transmission operators that we are leading a demonstration with electrochemical storage, and so it was very new for us, and we had to, let's say, catch up and understand how is the technology and how to specify it, what are the different safety procedures to install these equipments in our substations. So this was one challenge. And also, so there was a change in the regulations. It's now transmission system operator are not supposed, except in certain exceptions, to own storage. So we had to adapt to this. And for example, we had issue in the installation of one of our demo in the Canary Island because the situation was not so clear due to that.
But your
so
main
that's a challenge.
functionality was frequency, balancing, congestion management. How did you apply it?
Yeah, in our case, so actually it's all because the idea was to test all the functionalities
Sure.
from chemical storage to the grid.
Okay, thank you very much. And now let's ask Safi. What was the main?
Yeah, the main thing, as we said, this we had two options for the consumer support. I mean, for the reducing the peak load demand. I must say that we had a couple of PV generations as well in the consumer end in this demo site. So it's balance more focusing on these peak demand reductions, so that it can provide to the grid services during the peak time. So. And definitely charging these batteries when PV is available or in the off-peak time, and support as much as possible to the consumer demand. So that's from this point of view.
Low time shift, I would say, right?
Yeah, no time shift there actually. So that's only for the storage, but not the demand. So demand was actually fixed. So it's charging these off-peak time or the PV is available, and then discharge it during the peak time or the other times also in the load. So that's one side. And from the grid side also, to provide the grid services, as I said, it's to provide the primary operating reserve in the VPP mode. So that's also has been tested. So yeah.
Okay.
But it depending on the control method, as we said, this we can also use it as for the balancing in the network. Unbalanced issues we can reduce in the three-phase low voltage network, but it depends on the control. But we test we have developed different control methods and see that's which type of control method actually really could be helpful in future.
Okay, and Mia?
As in the storage demos, we had different aims, but we tested about everything, like load shifting, peak shaving, power quality improvement, stability and security of the grid, reduction of line congestion, voltage control, increased self-sufficiency, and increased sale of self-consumption. I didn't mention, but we also had a seasonal thermal storage in one of the demos. And in one of the sites regarding the self-sufficiency, we managed to receive 35 days of off-grid operation, and that's one of the results.
Thank you.
The functionalities were generally achieved pretty well. as long as the storages were available during the operation. And that's one of the things, issues, learnings.
Okay, I would like, now we have only 10 minutes left, so I'd like now to open a question to all panelists. If you would like to discuss a bit this cost-benefit analysis, do you think that is really cost-effective today to use storage for any of the functionalities? So who would like to pick up this question? Yeah.
Maybe I can start it. So that is what we hope, of course, because in setting up a new methodology that tries to see the advantages of taking profit of storage and flexibility for planning, we hope that the cost-benefit analysis, that the ultimate engine that we use in order to minimize system-wide costs, so OPEX plus CAPEX, and see among the wide range of candidates what are the best awarded in order to get investments in order to improve the system and solve congestion in case it exists and so on. So we hope so, and in that, also covering the last part of your question, we also internalize the main environmental aspects that are air quality, CO2 footprint, and environmental constraints. And in that framework, we use also a life cycle assessment framework. So we hope next year we will be able, before the end of our project, that will be in September 22, to provide the final results and the guidelines that we are going to elaborate.
But Gianluigi, taking into account the current situation, the current way the market and the benefits are,
in my opinion,
that this is cost effective?
In my opinion, there are some aspects that are very promising. For instance, the fact that the storage requires only a local investment and not a distributed investment. So from the point of view of the environmental assessments that precede every kind of network refurbishment, can provide a quicker solution, and sometimes a more effective solution whenever some aspects, some kinds of congestion are targeted, like for instance, variability of rest in some weak points of the network. In that case, maybe the effect of that storage can be similar to the one of a virtual power plant, and compensate what of that variability is provided to the rest of the network. So in my opinion, it can be very profitable, but the true economic assessment, I will repeat, will come when the 6 regional cases will provide their results, and we have to wait some time ago, sometime ahead.
Thank you. Anybody else would like to answer this question?
Yes, I would like to. This is
Please,
Mia Alajuusela from VTT. Actually, our finding was that regarding the environmental benefits, it requires quite a lot of renewable energies in the system before the battery energy storages come environmentally beneficial, because the grid obviously can receive quite a lot of renewable energies, and the other flexibilities also play a role in this. And regarding the economic analysis, the incomes are really small, as mentioned, from small pieces of revenue streams, and therefore you need to make a really good cost benefit analysis regarding the different or the sensitivity to these different aspects before when you are making planning the system. And then also that as I mentioned, the availability of the system, the storage is also very essential for the cost benefit for the revenue. So there also it's important. The control strategies come to a very important point in that sense.
Thank you very much. Kadam?
Yeah, so I'd like to say a couple of points here. Basically, as we said, this we are dealing with the distribution network and very much challenging. So definitely the storage where we are placing it's and how what technologies we are using and how the regulations are there, where in the network or in the geographical positions in these EU countries. So these variety, I mean the issues are actually defined that how the cost benefit it will be to put these stores in the networks. But I would like to say mention another important point here. Actually, as we are dealing with the distribution network and storage, and we are thinking that lots of storage in the distribution network in future, not only storage but PVs also. So basically, in the coming days, if we see that there could be a change in the demand pattern, the overall demand profile will be changed. So the other player in this network, the utility supplier. So we find that basically they have lots of impact. I mean, these solutions will have lots of impact on their business strategy and the future planning as well. So, which I think that somehow maybe still we are not giving much importance on that side, that how these stakeholders could be playing their role in terms of not only the supplying the consumers, but as well as their business, and also can they take this role for this aggregator that if you're thinking, or some sort of local market operator. So this sort of issues will actually raise and I think some sort of importance should be given on that directions as well.
So I understand that this is complicated. You have to take into account also the other way other things work. Okay, thank you very much. Now, I think Jean-Jacques wants to answer. Or...
Thank you. Yes, 3 remarks. First, we think that European Union need more storage hydropower, first for independency, and secondly for the security of the grid. However, these investments could not be provided by private investor with short investment return period between 20 and 25 years. By the way, pumped storage hydropower is largely profitable with long lifetime and long-term contract with 40 or more years. That's the first point. The second point, for every site, we do life cycle assessment. And for instance, the last one we observed for construction, operation, and deconstruction. We release 11 grams of CO2 per kilowatt hour. And for 80 years, it was 250 megawatt. And last point, according to the Green Deal, we have to do life cycle assessment, but we need as well multi-criteria analysis. I mean, selection of technology should be rely on other criteria. For instance, the energy return on investment, the local development, the mineral depletion, and so on. Thanks.
Thank you very much. Okay, I think if there's no other question, let me...
Nikos,
ask.
Yes, Franco here. There is a question on the chat regarding second use. I don't know if any of the presenter, the panelists, are involved in the second use of electrical vehicle battery in their storage project. What is your opinion? Is it really a sustainable, let's say, approach, or has to be seen, or still a lot of barrier?
If I may bring my point of view, I think that it depends. It depends on the cost and of new batteries, let me say, and in particular, the cost of recycled materials. If we have a very good and efficient recycling methods that can be full recycling to get new materials or direct recycling to revitalize materials we already have. This is in general. At that point, maybe the cost of a completely new battery will be so low when that's to use for second use the cells coming from, let me say, for vehicles as an example, to use in other storage from renewable will be, let me say, not so efficient. In fact, when you use for second use cells, the cells coming from other uses, in particular for electric vehicles, they are not as exactly the same state of health or state of charge, but mainly state of health. And so you have to equalize them to get exactly the same and balance. So this takes a lot of efforts, and it's very difficult. So if the final cost of materials also recycled and the recycling is very efficient, maybe the second use will be not so important. It depends. It's something that we have to see, but it's a very open discussion, if you say.
I think both questions were related, right, Franco? Both questions in the chat are related. And
yes, it's
I think
a matter of cost-benefit analysis at the end.
Exactly.
Our colleagues will be waiting for us in the main room.
Yes, I just wanted to say we have until 12:15 to join the conclusion session. So the link will be pasted in the chat. You can just click on it to join the conclusion session, or otherwise follow the last link on your access card. So at 12:15, if it's okay, we would like to proceed.
Okay, thank you very much, Senya. And let me thank all the panelists. Of course, on behalf of Franco and myself, I think it was a great session. We learned a lot, and we will try now to see how we can make use of it for the new IP. But certainly it was very interesting. I mean, there was a lot of good messages, good lessons. Thank you very much for your participation and your presentations. Very, very useful.
Thank you. Very interesting.
Thanks a lot, everybody. Yeah.
Thank you very much. See you. Bye.
Thank you.
Thank you, Nikos and Franco.
You're welcome. Thank you to all.
Okay, see you all in a bit in a joint session at 12:15. Thanks. Bye-bye.
Bye.